some simple rules. Instead of differentiating functions by first principle each time, we could apply some simple rules to speed up the process. Okay, so the first rule is if we have a function which is x to the power of n, the differential, basically what we do, we bring the indice down, so we have n multiplied by x, and then we subtract 1 from the indice. Okay, so let's do an example together. Say our function is 5x cubed. Our differential would then be 5 times 3, which is 15x, and then we minus 1 from this indice, so x squared. Okay, how about if we've got a constant in front of our function? We basically do the same thing. So if our function is ax to the power of n, our differential would be a multiplied by n, so we bring the indice down, then we've got x and we minus 1 from the indice, so we've got to the power of n take 1. Again, let's do an example. Imagine our function is 20x to the power of 3. Our differential would be 20 times 3, which is 60. Then we have x and we minus 1 from the indice, so x squared. Okay, how about if our function was just x? Well, that technically means x is to the power of 1, and so the differential, we bring the 1 down, so we have 1 x and we minus 1 from this indice, so 1 times x to the power of 0. Now x to the power of 0 is actually equal to 1, so we are 1 times 1. Remember, anything to the power of 0 equals 1, and 1 times 1 is 1, so the differential of x is just 1. What about if we had a constant in front of our x? Well, then the differential, remember this is to the power of 1, will be m times 1, which is m, and x to the power of 0. Remember, that equals 1, so we have 1 times m, which is just m. So let's do an example. If our function is, say, 10x, our differential would just be 10. Okay, because there's a 1 here. Multiply that by the 10, so you have 1 times 10, which is 10, times x to the power of 0. And x to the power of 0 is 1, so you have 10 times 1, which equals 10. Okay, and our last rule is if we have a constant, the differential would be, remember, if we've got a constant, that means x is to the power of 0, then you bring the 0 down, so 0 times any number is 0. So the differential of a constant is 0. Let's see an example of that. So if our function equals 10, our differential would just be 0, because you're going to bring that 0 down, so you have 0 times 10, which is 0. Some other rules. The second derivative of any function can be found by differentiating the function twice, and the notation we use for the second differential is d squared y on dx squared, or f double dash x. The sum rule. If you've got a function plus another function, so f of x plus, or in fact minus another function, we just differentiate each part separately. So the differential dy by dx is the differential of the first function plus or minus the differential of the second function. And now we're going to do some worked examples together to practice this. So imagine the question said differentiate y equals 3x squared plus 2x minus 1. Well, dy by dx would be, you bring 2 down, so it's 3 times 2, which is 6x, and then you minus 1 from this indice, so you have 6x to the power 1. You got a 1 here, you got to bring that down, so you have 2 times 1, which is 2, plus 2, x to the 0, which is just 1. Okay, and when we differentiate that, we get 0, so we don't need to write anything. So our differential is just 6x plus 2. Okay, how about the second example? Imagine our function is minus 4x cubed brackets 2x plus 3. Well, there's two ways we could do this. We could use the product rule, which we'll learn about later, or we can multiply this out and then differentiate. So let's do that. So f of x would be minus 4x cubed times 2x is negative 8x to the power 4, and minus 4x cubed times 3, which is minus 12x cubed. Now the differential, so you're going to bring these indices down, multiply them out, so you have 8 times 4, which is minus 32, and x, and we reduce 1 from this indices, so it's cubed. Take 3 times negative 12, which is 36, and reduce 1 from the indices. So that is our differential, minus 32x cubed minus 36x squared. Okay, last example, so a slightly harder one. Imagine our function is 2 on the cube root of x. Well, the first step is to write our function in indice form. If we had square root, that as an indice is x to the power of half. So if you've got cube root, that's x to the third. Okay, and now we want to bring this to the numerator, and to bring a number or prenumeral with an indice to the numerator, you just change the sign of that indice. So y is 2x to the neg third. Okay, so we've just changed the sign of the indice. Now we could work out our differential, dy by dx. So you bring that indice down and you multiply it by 2, which gives us neg 2 on 3. You write x, and now we minus 1 from that indice, which is actually minus 4 on 3. And it's convention to write everything in positive indice form. So this is in negative indice. So to make that positive, you're going to bring that to the denominator, and that changes that sign. So our differential, dy by dx, is minus 2 on 3 x to the power of 4 on 3. Okay, cool. Thank you for watching.